Now, I don't know, I'm not sure, a few of y'all might not have heard. The review is the review for the final is the review for the class. It's not my math lab, it's my final. It is 25 questions, multiple choice. Now, there's a lot of questions in the review covering whatever types that you might be hit with. So if you can do the review, you'll be sitting fairly good for that final. And your final needs to be taken between May 4th to May 6th. So I guess we'll get started. The first two problems that you see here are limits. There'll be limits on there. Another thing you could look at actually are your first two tests that you had in class. Those would be also very good types of problems to look at. One of these is easy and one's not so easy. Do you remember what you have to do to limits? Anybody? You all are going to be taking the final. I'm not. I made it. So do you remember what you have to do?
Don't you graph it first?
You could, but the easiest thing to do, remember when you have a limit, what you're wanting to find is the Y value that you're getting close to when you're given a particular X value. So when you're finding limits, the first thing you always need to try is direct substitution.
Okay, so substitute the -1.
Yeah. And if you
Okay.
substitute in the -1, don't look at your answers. Do the problem and then see if you've got one that goes with it. So if I put in -1, that would give me a -6 plus 5. A -1 there would give me a -5 minus 6. So it looks like I'd be looking for 1/11. So I would go with A on this one. Now, those were not the ones that gave you all problems. The ones that gave you problems was something like the next one. Now, this is, I printed this off from my math lab. It's in your homework, and it's titled Review for the Final. And it's open right now. It's a homework. But in number 2, let me scoot this thing back up. If I do direct substitution, in the denominator, I have 0. In the numerator, if I put -2 in, that would be a 4 plus 6 minus 10. I get 0 over 0, and that tells me I need to do something. Do you remember what? Starts with an F.
Factor.
Yep. I need to factor. This just says when I get 0 over 0, that's what was called indeterminate form. So my numerator has the same factor as my denominator up here. So let me put down x plus 2 in the denominator and in the numerator. And then in the numerator, you can either factor it by looking at the numerator or fill in the blank. In order for me to get an x squared here, my first term in both of my parentheses needs to be an x. For me to get a -10 back here, remember that's last times last, I would need a -5. These cancel. This is why you end up with 0 over 0, because the numerator has a factor that when you substitute in -2, I get 0. Now, once I've got this, my next part I have to do is find the limit of what I've got remaining as x approaches -2 of my new problem. And if I put -2 in, it looks like I end up with -7. Now, if you graph this, because I could graph this, I would end up with the same answer. I would have a hole at the point -2, -7 if I graphed the original. And remember how we would put on the left side maybe a -2.001, and on the right side a -1 point bunches of 9s, and that would help me determine that I'm getting closer and closer to -7. So I could graph it, I could, but the quicker way is just to factor it and then substitute in. So I could have both of those problems similar to that on there, or the harder of the two is number 2. You got to remember to factor. Now, how about getting derivatives if those two problems are okay? Because we did derivatives the majority of the class.
Yeah, I think that's probably the easiest.
Now, number 3, you'd have to rewrite it because you got to get the variable up from the denominator and get that variable out from under the radical. So there'll be some on there that you're going to have to rewrite. So in this number 3, that is x raised to the +1/5. I did write it down. There it is. If it comes from the denominator, you have a negative exponent. But since that the 5th root of x is in the numerator, it is not negative. I had some people put some negatives there back when we initially had this. And when you get your derivative, you remember to multiply, decrease power by 1. Then you look at your possibilities. And on this one, I know A, B, and C are already out of there. The only possibility is D here. So do not look at, the only time you look at the answers is if you absolutely, totally don't have any idea whatsoever, and then you try to eliminate any that you have issues with. So these are straight getting derivatives. Number 5 is another rewrite, as is 6. How about 7 or 8? Do you remember the tangent lines? Do we need to look at one of those?
Yeah, do you care to?
Yeah, I can go over one.
Guys, this is a review. You just let me know. I don't mind at all. So let me see. Which one? 7 or 8?
7.
Okay. So let me cover up the answer. So the equation of the tangent line at x equals -6. For us to find the slope, which I don't know the point yet, but for me to find the slope, this is where your derivative comes in. So let me rewrite f of x and see if this rewrite is okay. Remember, you need to see your coefficient, your variable, raised to whatever exponent. So let me get my derivative. 3 times 1/2 is 3/2. X subtract 1. So my slope, I find it by doing f prime of -6. If that's 54, you store that in. Slope is 54, so I got my slope. Now remember, I need my point. For me to get my point, I've got -6. And all I'm writing this down for is to tell you where I have to go. I've got to go back to the original. So my point, so x to the third, I got -108. I need someone to verify, see if that's okay. Am I okay?
Yes.
That's what I got.
All right. So then you got to go here. Or whichever way you go. This is the way I did in class. This is called point slope form. So I've got y minus my y value, slope, x minus my x value, $50. And after you do all of that, then you hope that there's an answer that matches it. I would go with D. So is that okay, guys?
Yes.
Mhm.
Okay. Let's see what else is on here. You see the word marginal. What's that tells you to do?
Derivative.
Derivative. So you need to go get the derivative of that cost function. Let me cover it up for right now. So I've got a pen manufacturer determined that the total cost in dollars of producing X dozen pens in one day is given by this function. Find the marginal cost at a production level of 70 dozen pens and interpret the result. So let's go find C prime of X. Let me make sure I did that right. So marginal cost at a production of 70 dozen pens. So C prime of 70. Now remember that X is dozens of pens. Okay. So the X is pens. This is cost. When you get the derivative, you're getting slope. And remember, that's Y's over X's. So to interpret this thing right here, that is your money per dozen. But guys, the only one I see that's anywhere close is this one right here is B. So you see marginal, you get derivative. In number 10, according to one theory of learning, the number of items, W of t, that a person can learn after t hours of instruction is given by this function, where t is between 0 and 64. When it also, not only if you see the word marginal like we had earlier, but if you see rate, okay, that means derivative as well. But then this particular problem, you've got to be able to rewrite the W of t in the correct form. So that would be 15t to the what?
Two-thirds.
2/3. So since they want us to find the rate, let's go get the derivative. See, 2/3 times 15, I believe, is 10. T, subtract 1. So I need to find the rate of learning at the end of 8 hours of instruction. I would substitute 8 in. So I think if you substitute 8 in, I believe you should end up with 5. See if you end up with that.
Yes.
Okay, now another thing, if you'll notice how they all say items per hour, guys, remember it's y over x. That's what slope is. Now your y here, your W of t, okay, that would be the number of items. So that is items over t in this particular case is time. And why I'm saying this is they might have up here 5 hours per item, where they just flip-flop that the words. So look at the words carefully, because they have to go along with what you know about slope, which is what the derivative is. So 11 and 12, only issues here is the e to the x and the ln. Remember, e to the x is its own derivative. So for the first term here, it would just be -6 e to the x. The derivative of the next term would be 7. The constant falls off. So the one I would choose here, once my pen moves, I would choose C. Usually I have people see derivatives better after they do integration. Just one of those things. The derivative of ln x is 1 over x. So that first term would be a -9 over x minus 5x to the 4th. So I would go with A on that one. Just be careful when you're getting the derivatives. Make sure it matches up exactly how you have it. Because A and B are very, very similar. One's negative, the other one's positive. So ln x, is that all right? The derivative is 1 over x.
Yes.
Now this whole page has logs. So it's just a lot of practice. Let's look at 15. Won't y'all try to get the derivative of that, and I'll get it. and we'll see if we're okay. Write down what you think, what letter it is. Y'all have an answer?
Yes.
Do you have D?
Yep.
D is the answer. Let me do it real quick. I like those. They're very, very quick. This one can be done in a couple of ways, but if I have an exponent back here, I like to bring it out front. That would make that 12 ln x. The natural log of x is just 1 over x. Another way that back one could have been done would be 4. Put that in the denominator. Get the derivative of that. You'd end up with 12x squared over x cubed. That would cancel with all but 1. But if you'll notice, if you use your power rule, it's just maybe just a tad quicker. So we all right?
Yep.
Anybody else? You want to see any more of those? (16) is another find the equation in the tangent line. So let's go get the derivative first. In my derivative, I just ended up with 3 over x. We all right, guys?
Yep.
Mhm.
All right. So my slope is just 3 over e. My point, if I substitute e back in this, I go get f of e. Remember, natural log of e is equal to 1. So the f of e is just 5 here. So I'm going to have y minus y value, slope, x minus x value. So it looks like C. Now, if you'll notice, mine's not written the exact same way. It's because when I write these, I always like it mx plus b, so I know immediately what the slope is. They just put x over 1 and multiplied the numerator and denominator. So even though it might not look exactly like yours, you should be able to choose the one that you need to. We okay?
Yep.
Yep. At 17, an experiment was set up to find a relationship between weight and systolic blood pressure in normal children using hospital records for 5,000 normal children, the experimenters found that systolic blood pressure was given approximately by that. Where P of X is measured in millimeters of mercury, X is measured in pounds. What's the rate of change of blood pressure with respect to weight at the 70-pound weight level? So notice I see rate of change. Go get your derivative. Probably on this one, what would be easier is to distribute that through. And then when you get P prime, that's a constant. That would be just 17.5 times 1 over X. So you'd end up with 17.5 over X. Substitute in that 70. Let me do that real quick. And I got 0.25, so I would have to go with B on that one. Now 18 and 19. 18, technically, you could FOIL that and get the derivative. When I ask you to find the derivative, I'm not telling you how you're going to have to do it, but I could do the product rule on that or FOIL it. And remember, in your product rule, if you've got y is equal to u times v, remember y prime is v times u prime plus u times v prime. So do we need the product rule? Are we all right there? Let me know.
Yeah, I'm good.
That's a 1. How about the other two?
I'm good.
You're good?
I'm good with those.
Okay. Quotient rule. Y is
Good.
equal to u over v, y prime. Remember your fraction bar. So v prime. If you'll notice, all of those have v prime down there. Or excuse me, good gosh. I'm getting ahead of myself. So I've got v squared, v times u prime minus u times v prime. Be careful of this one back here. If you've got more than one term, if you've got a binomial times a binomial, you have to multiply first and then change sign. You got to do order of operations. So do we need that one, guys?
No, I'm good.
Good?
I'm good on that one also.
All right, let's see what else. So in 20, another quotient rule. 21, they want you to find the derivative, or technically they're wanting you to find the slope at that particular value, but not finding the equation. They're just wanting you to find the slope. So again, the quotient rule, and then substituting the value in. 22, I do want to look at 22 a second, because I am not going to do the quotient rule on that one. Rewrite this. So y prime, I'm going to do my power rule now. So -5 times 4 is a -20. Rewrite. Decrease power by 1 times derivative of inside. So which one would you all choose?
C.
C. Yep. C would be the answer. And be careful with respect to everything. Now, guys, if you've done the quotient rule on that, not only would it have taken you maybe 3-4 minutes to do, but you still have to simplify after that. Anytime you have a constant in the numerator, do a rewrite like what we did back in chapter 9. Bring the denominator up and use your power rule. Those problems are quicker than product rule and quotient rule if you rewrite them. Let's see what else I got. So this one, that's power rule, or yeah, power chain rule. There, actually, 23 through 25 is chain rule. 26, that's your old LN rule. Maybe we'll look at 26 real quick. If you have a constant up front, you keep that constant up front. Draw your line. Remember that goes to the denominator. If I can write it correctly. And then get the derivative of that. Now, they might have done something. Let's look. If you'll notice, the exponents are a little bit smaller down through here. I have got x's, numerator and denominator. Got a tickle. So if I factor out an x in the numerator and the denominator, doing some comparing, I would go with B. All right, all right.
Yep.
All right, let's see what else is on here. There's a ton of problems. It's just a lot of practice getting you back. And like I said, there's not that many problems on the test, not compared to this thing. 27 is another derivative where you have to use your chain rule. And let me see, they want the tangent line. So with us having, let me see, I think this is about the 4th or 5th problem. There, expect 1 or 2 on there. 28, concentration of a certain drug, rate of change. There's the words right there. That means go find your derivative. This you have to use your chain rule on. So exponent times coefficient, rewrite, decrease power by 1, times derivative of inside. Remember all the bits and pieces. And once you've done that, then substitute the t-value of 12 in and see which one of those matches up. '29 is the E again. Remember, you write this whole thing down times the derivative of the exponent. So I would be multiplying this by -5. I should end up with a -30 e to the -5x. Now, those problems prior to this were multiple choice. The whole test is multiple choice, so this is still working out a problem. LN, here's an example of one that there's a constant up front. So I'd have 9 times, draw my line, put that in the denominator. The numerator would be 14x, and then you clean it up. Now I need you to look at the difference between 31 and 29. In 29, I have just a constant. In 31, I have an x. If you count your number of x's, guys, this is considered one term. If you count your number of x's and you've got more than one, then you're either going to have to use product rule or quotient rule. So I've got to use product rule on this one. So indicate who U is, who V is, and then use your rule. Do we need to see 31?
Sure.
Remember, I like doing these problems. So in 31, they might have that answer, but if you look over there and if it's factored, then see if you can see. Actually, if the answers are in factored form, you can multiply those back through to see which one matches up with yours. Are we okay?
Yep.
Yep.
Mhm.
Okay. All right, let me see what else is on here. Increasing local derivative test. This was your, let me see, the test right before the last one. You got to go find your derivative, graph it, and do your sign chart. Once you do your sign chart, remember to sketch a rough sketch of what the original curve looks like. And it will help you to do these two. For max and mins. In this one, they want us to determine intervals where that particular function is decreasing. So I would be looking on my sign chart for any negatives that might be there. Do you remember this, guys?
Yes.
35 is getting the second derivative. Remember, to get the second derivative, you've got to first get the first derivative and then do it another time. I'm asking for second derivative there. For, let me see, these problems, 37 through 39, concave up, concave down. What derivative do you need to get in order to do that?
Second.
Second. So you got to get your second derivative. You get your first, go right through it, get to your second, do your sign chart. And instead of doing straight lines to represent slope, you do baby parabolas. Inflection points, if you see inflection points, again, that is where concavity changes. In this problem, they just want X values, but you get your first derivative, get your second derivative, graph it, find your zeros. And when you find your zeros, then you're going to be finding the X values of the inflection points. Now, if I want the actual coordinate, I would take my X value, put it back into the original to get the Y. Do you remember that?
Yes.
Actually, that's what we were actually talking about before we went on spring break. So this problem 40 is similar to what you had on the test, where you had to find the critical numbers, find it where it was increasing or decreasing, and local max or min. So 40 is sort of a conglomeration of that prior page. So what about integration, guys? How do you feel?
Pretty good.
On these, as before, get it in correct form. But if there's a problem you run upon that you have any difficulty with, now what I'm about to say might take a little bit longer, but you would still arrive at the same possibility, is get the derivatives of these. And since the back end looks so different from the rest of them, then you could almost start at the back end. So there's always, in a multiple choice test, there's always a couple of ways you can go. So there's a bunch of integration. I see U substitution here. These are pretty much U substitutions, every one of those. Any of these you'd like to see?
No, I feel pretty good.
Now, since this is a multiple choice test, to save time, this type of problem here on 47, since it's asking us to evaluate, I'd use my calculator. Now, if you graph this, be careful, because if you're on your Zoom 6, your X value in Zoom 6 only goes to 10, and it will give you an error message until you go in and you send that X max up to say 20. Let me do, this one ain't going to take that long since I can do that. Well, let me leave it as 10 so you'll see what I'm talking about. Now, if I do my second trace for the calc menu number 7, and I go from 0 to 16, that's what I'm saying. If my window, okay, go to, let's just quit a minute. If I go to my window and go down here and make that 20, let me go graph. Second trace for the calc menu number 7, 0 to, that's sort of cool on the screen. I would go with D. It can run out Y value wise, but X value wise, if you run up to that, it ain't going to work. All right. So same thing on those. 51 should look familiar. Y'all did fairly well on those. The only thing is, please be careful and know if you go left to right in this particular problem from A to C, there's 1, 2, 3 sections I have to account for. And since I am going left to right, A and C will be positive, B will be negative. So there are going to be some of these on there. (53), 54. Those are the ones I'm telling you that you need to be careful on, because they're going from C to 0. Here's C. 0 is right here. Since I'm going right to left, signs change. So this will be a negative 5.845. Do you remember that, guys?
Yeah.
Okay. So there are a couple of those. They're quick. Don't worry about 58 because we don't have average number. So you don't even worry about that one. But these are some others that you could do via a calculator. Oh, me. Find the integral over the interval 0 to 9. So you'd have your function and you're going from 0 to 9. You'd be able to answer that one. We had one of these on the test, total accumulated cost. Or actually, I know we had it on the review. I'd have to see if we had it on the test. But remember, you've got to set these things equal to one another in order to find useful life. And once you find useful life, they want it to the nearest year, not tenth of a year, but nearest year. Then you have your integral. And since they're talking about profit, remember profit is always revenue minus cost from 0 to the useful years. This is finding areas. You need to graph them and make sure everything's positive. In these two problems, 62 and 63, you could do that via a calculator. Since it says the word area, if you do the absolute value of these over that particular interval, you could graph it. The C answer here on 63, no. Area can never be negative, so that one's automatically kicked out. On these particular problems, you graph on 64 and 65, graph them, and it's always top curve minus bottom curve, like revenue minus cost. As long as revenue is over cost, you're going to have a profit. So you graph top curve minus bottom, set up your interval. Now here it's bounded, so that means you got to find where they hit. Same thing with 65. Do you want to see either one of those?
Yeah, could you do 65?
Yeah. Find the area bounded. Now, guys, automatically this one down here is a no. No negative. So first job is you graph these. So let me do 6x minus x squared, and then x squared minus 2x. Now the first one that's going to graph is this one. It's going to be blue. This one's going to be red. Another thing, this one is concaved down. This one's concaved up. So I'll know which one's which. Let me go back to Zoom 6. Okay, where there is an enclosed region is right in here. So my top curve is the one that's concave down. Subtract bottom curve. So it's 6x minus x squared plus 2x. So I get a negative 2x squared plus 8x dx. So I've got that part ready. I've got to find out where they hit. So second, trace, intersect. It's very close right there. Let's see if they hit there. They hit at 0. And now I'm going to move it up to where they hit at the other location. Hit at 4. So this simplified one down here would be the one that I would put in the calculator. Now, if I want the calculator to do the work, I'm going to go back up to this one right here. Go minus x squared minus 2x, as if I was just doing this top one. And that lets the calculator do most of the work. Let me ask it to graph. If you'll notice, from 0 to 4, my new parabola is completely above, which is what I wanted. So second calc, number 7, 0 to 4. So it looks like the 21.333. Now, the one that was on the test, I actually gave you an interval to do. But if you're not given an interval, then you have to find the intersection to see where you got to start at and where you end. So is that one okay?
Yeah.
And I think that's it, guys. That's all the problems. So if you want, some more practice, then there were some problems that I didn't do. Are there any questions that you got?
Will the final be on Brightspace?
No, it's in my math lab.
Okay.
And it opens up on next Monday, the 4th. Is that right? 1, 2, 3, 4. Yeah, it opens up Monday, and you got to get it done by the 6th.
Sounds good.
Is that all right, guys?
Sounds good to me.
Well, it was nice having you all in class, and I'm sorry it ended up this way, but it wasn't all that bad, really.
No, it wasn't too bad at all.
Just a little, just something to get used to. But I thank you for coming in and, just get it done, and because y'all are doing well, so everybody's okay. So take care. And are y'all taking any classes in the summer?
No.
I'm not.
Nope.
No. Well, they're supposed to be all online, just like UT. So hopefully they're still discussing fall, and they're talking right now about the number in classes. You're not going to have a class, I don't think, of 30 plus anymore. Not for a while. So they're talking about, going back and getting eye to eye again. So you all take care, okay?
Ew.
All right, you too.
Have a
You
good
too.
summer, guys.
Y'all.
Bye-bye.